I thank God for the opportunity that we're still in the land of the living. We have seen many of our friends and family members affected by this pandemic, and no doubt wherever you are and whoever you are, you have been affected in some way. So my goal for this evening is to give you just a little bit of an overview of what this disease is and what the causative agent is, and hopefully be able to answer your questions that you might have about this disease and how it works and what it is that we can do to protect ourselves. So I'm going to be sharing my screen. And I will have a video in there as well that I will play. All right. Okay, so you should be able to see my screen now. And so essentially, the first thing I want to say to you is that the human population has always dealt with pandemics. Over time, and you don't have to be able to read through this, I just wanted to show you the landscape of pandemics from as far back as the Antonine Plague, which many believe was caused by maybe the smallpox or some other terrible disease that affected humanity. You fast forward to the bubonic plague, 1347 to 1351. This is by far the worst pandemic we've ever had. And bubonic plague is caused by a bacterium that was readily transmissible and killed over 200 million people. At that time, that was vastly the almost half of the world's population. Then you get to smallpox that ravaged the planet throughout the 17th and the 18th centuries, ended up killing about 56 million people, ending somewhere around 1520. And then we went on and we've had cholera outbreaks, we've had several other outbreaks, and we reached the Spanish flu in 1918, 1919. And that's probably the one that I think we can most draw from because it is closest to our current modern civilization. And the way it was spread is also closest to the way this pandemic flu is being spread. But the Spanish flu became known as the Spanish flu because it happened right around World War I. And at the time, because so many countries were fighting the war, they did not want to tell their people that this terrible pandemic was happening and it was causing the death of so many people. They tried to hide it so that they wouldn't bring down morale. It became known as the Spanish flu because the Spanish people, Spain wasn't a part of the war. They were neutral. And as a result, they were very honest in reporting the number of cases that they were having. And so it seemed to many that they were having a worse pandemic than others were. And so this Spanish flu killed about 40 to 50 million people. And you might ask yourself, why is there's such a wide gap between how many we think are killed? I mean, 10 million is a lot of people to have uncertainty about. The reason for the uncertainty is that it wasn't clear what was killing people. The war was going on. We know that it killed more than people than happened in the war. And because so many countries weren't reporting it, it became difficult to track. So what I want to do a little bit is that I want to bring you back to 1918 just for context. And this is a newspaper article from the Seattle Daily Times. And as you can see there, like what we have today, churches, schools, movie theaters, they're all closed. Why? Because of this very serious pandemic. And to bring you even further, I'm going to play a little video for you so that you can get some of the essence of what was happening there, and then we can pivot.
One of the worst natural disasters in recorded history was caused by a virus. The influenza pandemic of 1918 struck every major U.S. city, dropping people where they stood.
Oh, so I can see that the slides are not full screen. I'll reduce that and I'll get right back. We just stopped sharing for a minute. Didn't realize that. You can always stop and tell me if something doesn't look right. Let me pull that up again, and I will, you can share how, give me a thumbs up if I'm full screen.
There were at least 20 million people killed worldwide. And
Are we good? Full screen? No?
No.
Okay. Try that again. Sorry about that. Technical difficulties.
it's probably the worst pandemic the world has ever known.
Okay. I'll fix that in 1 minute. Having two screens actually made this a little bit challenging, but I'm going to change that right now. Okay. I think I got it. All right. All right.
One of the worst natural disasters in recorded history was caused by a virus. The influenza pandemic of 1918 struck every major U.S. city, dropping people where they stood.
There were at least 20 million people killed worldwide. And it's probably the worst pandemic the world has ever known. There were more people killed from influenza than there were from the First World War.
The war itself was the problem. If there had been no war, that year's strain would have stayed isolated. But when Allied troops met in northern France to exchange fire with the enemy, they also exchanged a lethal strain of flu. So it began.
It then went from France to the United States and disseminated from Boston.
At Fort Devens, Massachusetts, one case of flu turned into more than 6,000 cases between September 1st and September 18th. It took only 17 days. India lost nearly 4% of its population. Alaska, 8%. In the South Seas, the death rate was 20%.
People were absolutely panicked because somebody could be playing bridge one night and they would be dead the next day. And so they did all kinds of things. They were wearing face masks, and in fact the police all wore face masks. They were carrying little pouches of garlic and onion, just anything that they thought would protect them from the flu.
They had no idea that they were leaving exposed the very place where flu enters the body, their noses.
Nothing was known about how to cope with it. And that is something that began to emerge when we got into the 1930s, 1940s, and 1950s. By that time, there was enough knowledge and experience and the development of techniques to make it possible to proceed.
So I also want to show you this graph of what happened in 1918. The first wave that you see there, that first little curve of the that started in June, was the first wave of the virus, like what our first wave looks like now. And after that, people became comfortable. They started opening back up. They started going out. And then the second wave started right around September. And as you can see, the important thing to see about this is that the second wave caused the death of more people, 5 times, sorry, more people than the first wave did. This is really important because these infectious diseases, they don't intend to kill us per se. Essentially, all they want is to be transmitted. They really just want to get from one person to the next. But in doing so, they will do that at all costs. And as you can see, there was a third wave as well. The second and third waves were all worse than the first wave overall. So what is causing this? Like the influenza pandemic, this is being caused by a virus. And viruses are really small. In fact, with a regular microscope, what we call the light microscope, you cannot see a virus. You can see a cell under a light microscope, but viruses live in cells. In fact, viruses not only infect our cells, they actually infect just about everything that's cellular. Plants, animals, you know, fish. In fact, it is estimated that 1 milliliter of seawater contains about 1 million different viruses in there. So viruses are ubiquitous, they're everywhere. And they're small enough to even infect bacteria. Most bacteria have viral infections in them. We call them bacteriophages. And so as you can see, viruses are really, really small. And essentially, you might say that they're not living, they're not alive until they have entered your cells. They don't have the machinery to propagate themselves. They can't make more of themselves on their own. So they're what we call obligate intracellular. They must get inside of a human or animal or plant cell in order to replicate. And so what you're seeing there is the cartoon. That first one is the cartoon of COVID-19. But right beside it on the right, what you're actually seeing is an electron microscope. This is a high-powered microscope that we're seeing the virus on. And the virus actually has these spike proteins on it. And so the word corona actually comes from the Latin word meaning crown. So that's how it gets its name. This family of viruses, they look like a crown. You can see the little spikes around it, and it gives it the shape of a crown. So that's how it got its name. And so the disease itself is called COVID-19. It is coronavirus disease 2019. So that's how the name came about. And that's different from the name of the virus, which you probably hardly ever hear. But this virus is called the severe acute respiratory disease syndrome coronavirus 2, so it's SARS-CoV-2, because in 2002, 2003, we had another coronavirus disease that was called SARS coronavirus. So just to give you an idea of how small these viruses are, over 1 million of these coronaviruses could fit on the head of a pin, right? So that's how tiny we're talking about, really, really small stuff. And so this again is an electron micrograph actually showing you the virus itself. So all of each of these little particles is a virus inside of a cell. That's a cell nucleus. You're seeing that blob in the middle. So that's a little bit of physiology. But the question is, how does a virus like this make it into your cells? How does it get into our cells? And our cells have proteins on its surface that actually help our bodies to function. And these proteins are like little hands sticking out because our cells don't have eyes and ears and nose. So the way they know what's going on around them is that they have these little proteins that are sticking out of their surfaces. And that's what the virus actually binds to. So I'm going to play another little video for you so that you can appreciate the concept of this in cartoon form. So what you're seeing there is the little trail that you're seeing is the virus. And it's coming closer to the cells. As you can see, it is closer and closer to that cell. And on the surface of the cell are those proteins I'm talking about. Those are the proteins that the cell used to function normally. These weren't made for the virus. It's just co-opting them for its purpose. These are necessary for normal cellular function. And as it comes closer, it binds to the surface of those cells. So you can picture almost like a Velcro, the negative and the positive end of a Velcro, and it sticks. And typically it requires several of those Velcroed areas to stick. And once that happens, once it sticks and holds on, then the virus gets pulled closer. It's almost like you're trying to climb a wall and you have one hand up and then another hand, and you hold on and you're able to pull yourself over. So the virus is now able to bind to, pull itself closer to the cell, fuse with the cell membrane, and then it's able to get into the cell. And all it needs is just for this genetic material that this virus has, in this case RNA, to get inside of the cell. And then the virus can replicate fully inside of the cell. Now, with this, we come to this place where we are. We're currently worldwide, we have over 3.9 million cases of the coronavirus. By the time the middle of next week comes, we would have cleared 4 million people worldwide who have been infected by the virus. At this point, the US has about just under 1.3 million cases. And as you can see, worldwide, over 276,000 people have already died. 77,000 of those are in the United States of America. So I mentioned before this SARS virus that we first encountered in 2002. This was not the first coronavirus that we knew about. Coronaviruses have been known about since the 60s, but the ones that we knew, this didn't cause this type of a disease. They caused what we call the regular cold, and I'll get to that. But as you can see, in 2003 going into 2002 going into 2003, we encountered this SARS virus, and what essentially it caused this SARS-CoV-2. CoV-1 is the virus, caused this syndrome that killed about 800 people after infecting about 8,000 people. So that's a 10% death rate. This was significant at the time, and a lot of research was done on it as well. In 2012, we saw a cousin of this virus, and most people in our Western part of the world don't know about this because it actually infects people almost exclusively in the Arabian Peninsula because it's transmitted by camels. It comes from bats to camels, and then from the camels to humans. So we haven't seen direct human-to-human transmission. And of course, the current coronavirus that we're dealing with, we encountered it in 2019. So the thing I want to share with you is that bats carry a lot of viruses. Some of the worst viruses that we know, Ebola, Hendra, these terrible viruses originate in bats. Bats are unique. They're mammals, and they like social settings the way we do as humans, with one exception: they can fly, which means that they can move from one place to the next in a very short time. And because they're so social, they can transmit whatever they have from one person to the next, from one bat to the next in a short period of time. And so the 2002, 2003 virus came from bats and then got into a cat, civet cat, and from those cats got into humans. This current outbreak, we're not sure how it came, but this is actually a genetic tree. This is a family tree of these viruses. And each little blob is where they're closest. And you can see that this is where the current virus, indicated here in yellow, falls, and it falls very close to this bat coronavirus. So I know that there's some people who are saying that this virus escaped from a lab or it's man-made. Just not true. The genetic sequence shows that it is very closely related to the natural bat virus and also closely related to that 2002 SARS virus. And I can have more discussions on that with you. The other viruses that you see there in red are the ones we knew about before. In fact, we thought so little of them that we didn't even give them real names. We just gave them codes, right? And they cause the common cold, right? These ones there, you see what the H is for human coronavirus. And so they cause the common cold, and we see them all along. Now, here's the problem with this new virus, this COVID-19 agent. The problem with it is that, unlike all other diseases that we've seen before, this one can be transmitted from somebody who shows no signs or symptoms of the disease. And that makes it really, really challenging to deal with. So essentially, when people are sick and they're coughing and sneezing, you stay away from them. They feel too sick to come out anyway. And so you typically don't have transmission readily from those individuals. And so the way we stay one step ahead of this virus, since it can be transmitted without any signs or symptoms, is that we have to get to the place where we're testing way more people than we're doing now. So this is a simulation that I want to show you of what a cough or a sneeze looks like and how readily this virus can be transmitted from one person to the other in a setting like a work setting or a church setting overall. And this is why the physical distancing becomes so important. So, oops. So let me play this for you.
About 10 people in an enclosed space the size of a classroom. A person coughs once and spreads about 100,000 droplets. Large droplets are shown in blue and green. Most of these fall to the ground within 1 minute. But the microdroplets, shown in red, continue to drift. This simulation uses only microdroplets. 5 minutes later, 10 minutes later, "20 minutes later, the microdroplets are still floating in place."
And so essentially, that's the reason why we have to be so thoughtful and careful about what we touch, the surfaces we touch, and being in an environment where somebody could potentially be infectious. So this chart is actually showing you what researchers discovered about a month and a half ago about this virus, that it can sit in aerosols like the one I just showed you there for about 3 hours. It could still be hanging around. In other words, you could walk into an elevator or a room and somebody left there an hour and a half ago who had coughed or sneezed, and they have COVID-19, and they probably have no signs or symptoms, and you walk in now and you could actually have the virus that you could pick up. Copper is a surface that actually kills microbes, and so we don't expect that it would live very long on copper, so up to about 4 hours. On cupboards, on cardboards, and wood and those surfaces, it is thought that it could live from anywhere from 18 to 24 hours on those surfaces if they're not cleaned off. But of course, the surfaces that we're most concerned about are the plastic and stainless steel, because the virus could potentially sit on those surfaces for up to 3 days if it is not exposed to direct sunlight or other types of environments of heat and light that would kill it. So this virus is by no means a very tough virus. It's very easy to kill, but you just have to get the right agent on it. You know, heat will kill it. So will disinfectants like alcohol and Lysol and some of those, anything with a detergent in it, will break down that surface that you see on the virus. So again, our challenge with it is that you can actually have a person being infectious day 1, day 2, maybe day 3 of being infected. They could be infectious but show no symptoms. After symptoms appear, we know that this virus can still be shed by an individual up to 20-something days after. They could potentially be shedding viruses and could potentially transmit it. And so that means that testing is needed in order to confirm. The good news is that 80% of people who are exposed to this disease, who get infected, are almost totally fine. They have very little to no symptoms at all. We have another 13% of people who, when they get the virus, they have severe disease, but only a small number of individuals, about 6%, actually have disease severe enough where they need life-saving measures to be implemented. So the virus can infect a whole host of cells in our bodies, from our eyes, our nose, into our throat, into our intestines, blood vessels, kidney, liver. It infects a whole host of cells in the body. But once it gets into the respiratory tract, which is where we typically see it, in a severe case, it will cause shortness of breath. And this is just showing you that what it does, it actually leads to the alveoli, these small sacs in the bottom of your lungs, filling up with fluid. And that fluid is not directly a result of the virus. It's actually your immune system responding to the virus. And that leads to what we call a cytokine storm. These are chemicals released by the body. That's why you have a fever. It's a direct response to that type of molecule that is released. And in some individuals, when that happens, you start having this fluid accumulating. And the only reason you need a ventilator is because you have fluid in your lungs, so the oxygen that you inhale can't get through that fluid to get past this membrane into your red cells, which are sitting right there, starving for that oxygen. And so they use a ventilator, a mechanical way of forcing the oxygen into your lungs through the fluid so that you can actually get oxygen into your body. That's a worst case scenario. That's in severe cases of this disease. But again, most healthy individuals who do not have underlying conditions seem to do pretty well. And what are those underlying conditions? The most consistent one seems to be hypertension. For people who have high blood pressure, for people with diabetes, for people with other cardiovascular diseases, it seems to be a big issue. Probably people with COPD and asthma as well, although a new report seems to suggest that the receptor that this virus binds to, the ACE2 receptor, is of, we have it in lower numbers in the lungs of people with asthma. So they might not get as easily infected as other individuals. But if they do get infected, it would be a significant problem because they already have a breathing issue. And so this whole idea of social distancing becomes important. As you can see there, if you reduce social exposure by about 50%, you can see that a significantly small number of people get infected. But if you increase that by just 25%, over a 30-day period, you can see that significant increase in the total number of people getting infected. And then if you actually have no social distancing measures, as you can see, a significant population can become infected in a very short period of time. And so that's why the social distancing is important. We talked a lot about flattening the curve, but that now has less to do with the individual than it is to do with the capacity of the healthcare system. Flattening the curve just means that you have less cases than you have beds for and ventilators and those things. And so luckily that has happened in pretty much every US city at this point in time. I just wanted to show you this last slide with this chart. And this is a case study that happened in China. It's about 200 and something miles out of Wuhan earlier this year. So this is in January. So A1 in yellow is a person who traveled from Wuhan with her family. Table A, they're all family members. And this family member was infected but had no signs or symptoms of the disease. They sat there to eat in this restaurant. And by the time they were done and left, this one person had infected another 4 people at her table, right? However, she also infected 3 people at this table and 2 people at this table. I want you to notice that there's an air conditioner on this right end of the room, and it's blowing air over all 3 tables, and then it's hitting a glass wall over on the left-hand corner that you're seeing there, and literally bouncing back. So essentially what it's doing, it picked up whatever, when she was talking, saliva and stuff that came out of her mouth, maybe she sneezed, it's not clear. It picked that up and the air conditioner kept on pushing it. It bounces off the wall, comes back over all of those 3 tables. And that is the way it is expected that those individuals got infected. And I think I'll stop there because I think overall what this shows is that there is an easy way to infect individuals, and that essentially when that happens, it becomes very problematic for those who are in the vicinity. And you probably have lots of questions because I purposely kind of left things hanging for that reason, and I'm happy now to answer questions that you might have.
Thank you, Dr. Webley. In order, I'm going to turn this over for a short moment to Brother Dwight, because I'd like him to go through how we're going to handle the questions. So at this time, we'll just swing it right back to Brother Dwight, and then we'll come back to us in a minute.
Thank you very much, Dr. Webley, for going through that. The information was great and awesome. To all of the participants in the room, we have more than 100 of you here, and we understand that you are very interested in putting your questions to the doctor right now. We want to accommodate as many of you as possible according to doctor's time. So what we're asking for you to do is use these two methods. Number one, if you are on a phone, we're asking you to use the *9, raise your hand. We will acknowledge you and we will unlock your phone when the time comes. For those of you that are in the line and you have a computer or phone, we're asking you to send us a chat and we will read the chat to the doctor. This way we can get through a lot more questions than bouncing over each other. And in some instances, we will unlock you if we see that you have your video on and you can ask a direct question to the doctor, but we'll do that as needed as the time goes along. So I'm gonna pass back over to Evangelist Hector.
Great, great. Thank you so much, Dr. Webley, for that discussion. Now, I have a quick question, actually. You mentioned that heat will kill it. So what does that mean in terms of, now that we're on the backside of this curve, if you would, and I do understand the flattening of the curve is more in capacity of what the hospital can manage and all that, but we are seeing a significant decrease in the deaths that we were having in New York. Just as an example, we were trending like almost 900 deaths per day for weeks. Now we are down to maybe 200 and something. But what heat will kill it, what does that mean to us now that we're entering into the summer? Does that mean we stand less of a chance of seeing the virus take off again on us?
Good, very good question. I think the research currently shows that for every 2 degrees we go up in temperature, the infectivity of the virus will probably drop by about 1% or 2%. And so clearly heat will kill it, but here's the thing. We know that temperate areas of the world, including Africa and the Caribbean, and the western parts of the country have not been exempt from the infection. Why? Because most of us are probably not getting infected outside. We're getting infected inside of buildings where there's no direct sunlight. We're probably getting infected by touching surfaces. We're probably getting infected by being in direct contact with the people who are transmitting the virus. So your body temperature is not gonna go above 37 degrees unless you're sick. The virus thrives at that temperature. You need to be above 50, 56 degrees Celsius in order for the virus to start having significant problems. And so while the ambient outside temperature is a factor, and we know that increase in temperature, increase in humidity will make those small droplets fall faster to the ground, and so the virus is not hanging around as much, that only describes outside and not inside of any buildings or environment that somebody might be hanging around.
Dr. Webley,
Yes.
I have 2 questions. Maybe you can join the 2 together.
Okay.
Number 1, I had a question about air circulations. That was a really good model that you showed, and I think a few people had questions about that.
Yeah.
And the second is regarding next year's or the upcoming flu season and what that means for school reopening and how that coincides with the normal flu season.
Yeah. And, you know, as a professor, these are questions that we're wrestling with. We want to determine whether or not we can open up for the fall and how safe that would be for individuals. Now, here's the thing. The threat of this virus is not going to go anywhere until we have a vaccine. So until we actually get a vaccine, we're not going to return to normal, to our normal activity. In other words, social distancing will still have to take place, all right? If you're in a building, if you're in a room where you're locked with other people, for example, for 2-3 hours in terms of going to work or going to school. All it takes is one person in that area to become infected with the virus and breathe and talk. So sometimes we don't really notice that when we breathe, micro droplets come out of our nostrils and out of our mouth and go into the environment. Picture yourself on a cold winter morning when you walk out, and when you open your mouth, what do you see? You see almost like smoke is coming from your mouth. All of that is micro droplets coming from your throat, coming from your mouth as you breathe. So you have to think about that. That's what the virus rides on to get out of your body into somebody else's space, or to get out of somebody else's space into your space. And what that means then is that if you're not 6 to 9 feet away from somebody when that happens, the probability of them transmitting that virus to you is going to be increased. So what will school look like in the fall for the schools that actually reopen in the fall? I think they're going to have significantly less than their capacity. I think they're not going to be able to bring everybody back into school at the same time, because it will be very difficult to obey social distancing or physical distancing norms if you do that. And so right now, my university is one of many who are considering this. I think in addition to having healthy social distancing norms, there's going to have to be extensive testing. The testing capacity will have to far exceed what we're having now. If you're testing and you don't have less than 10% of the population testing positive, the people you're testing positive, then you're not testing enough, right? And so that will have to happen. Where flu season is concerned, that's such an important question, because when flu season starts, the symptoms are going to look so much the same. And if you actually get the flu and get the coronavirus on top of that, which is totally possible, you could be in serious problems. And so I think if we continue to obey the current social distancing norms, not only will we avoid getting the coronavirus, but we would significantly decrease the number of flu cases that we have.
Thank you, Doc.
Can I?
Oh, I'm sorry.
Brother Dwight, I'm just going to ask a question on that. So you mentioned the vaccine, and you also, and I think that's important, because I heard Dr. Fauci make mention of the fact that, and I think the head of the CDC, that the vaccination was 12 to 18 months out. And then he came back and said, well, maybe we'll have it available in January. How realistic is that timetable? And with that being said, how safe will it be? Because for me, and I think for everyone, you don't want to rush to market with a vaccination that might cause more harm than good. So how long does it usually take for these vaccines to be done?
That's such an important question. Up to this point, we have never had a vaccine that was produced in under 4 to 6 years, right? That's number one. Number two, vaccines are different from any other medication that you would possibly take. Why? Because if you're taking an antibiotic or an antiviral or a blood thinner, you're taking it because you have a disease that you're trying to treat. So what they're doing is that they're balancing the risk versus the reward. In other words, you could literally get a drug to treat your cancer or something else that is more likely to kill you than to help you. But at the point, they have no choice, because it's either you try that or you're going to surely die. That's not what happens with vaccines. In fact, if you're sick, you're not getting a vaccine, right? When you go to get a vaccine, like the flu vaccine, they ask you, have you been sick? Do you have a fever? They don't want to give you the vaccine if you've been sick. Why? Because you give vaccines to healthy people so that healthy people can make an immune response to it, because that's essentially what a vaccine is. It's you priming the immune system for something it hasn't yet seen, so that when it sees that thing, you don't get the disease, because you have cells now, memory cells and antibodies. These are protective proteins that the body produces that helps you to neutralize it so that it doesn't even get inside of the cells and you don't get the disease. Now, the safety part of that is what concerns me. I'm not saying that we can't make a vaccine in 18 months, but I wouldn't want to scale up a vaccine that is made in 18 months to give to the entire population. I would want to see that vaccine given to every demographic of the population and see what happens after 6 months, after a year, after 2 years, 5 years maybe, before I could say that vaccine is absolutely safe. Why? Because there have been many cases. I work on vaccines. That's what we do in my research lab. And many times a vaccine works perfectly well in your mouse model or your rat model or your rabbit model. And when you go to humans, not only doesn't it work, but it makes things worse. A good case study for this is HIV. They have dumped trillions of dollars into HIV vaccine research. We've had several HIV vaccines go to clinical trial, phase 2, phase 3 clinical trials. All of them have been pulled. In fact, the last one that they did in South Africa looked really good in phase 2 clinical trial because they were like 200 or 300 people who were getting it and it seemed like it was protective. By the time they reached to phase 3 clinical trial, where they expanded the numbers, they started realizing that not only wasn't it protecting people, but the people who actually had it were more likely to get HIV than the ones who didn't have it. Why? Because it was actually enhancing the infection. The antibodies, the proteins that were being made, were binding to the virus and helping the virus to get into the cells rather than blocking it from getting into the cells. So we talk about these different types of antibodies, these neutralizing antibodies that are absolutely essential if you're going to prevent infection. And we just don't know if the current vaccine antigens that are being produced are actually doing that. Are they neutralizing? And that's what has to be tested. And it has to be seen if the vaccine is actually enhancing the infection or actually helping the person.
Great.
So,
Brother Dwight?
Yes. So, Doc, we have a lot of questions coming in, and a lot of them are sort of overlapping. So I want to try to get as many to you as possible. And for everyone else, please keep them coming. We see some hands raised. We'll get to you in one moment. So, Doc, I'm going to put this to you, several questions together. We had several people ask about testing. Number one, if a person who's asymptomatic, should they be tested? Number one. Number two, how often should they be testing? And number three, it was, when will mass testing be available? Those are all the testing options.
Yeah, and so when will mass testing be available? When the federal government gives states the resources that they need in order to scale up. And individual states are trying to scale up. My own state, New York, has scaled up significantly their testing and continue to do so. But the truth is, at the state level, at the local level, you do need resources because some of the reagents and supplies and equipment that are needed, the federal government is now in charge of those. And they're very difficult for individual states to get. In fact, what was happening is that states were competing with each other to purchase these. And so there needs to be a scaling up at the federal level in making monies available to the states as well as making supplies available. These are the diagnostic test for this disease is a test that amplifies the nucleic acid, the genetic material of the virus. In other words, you can take a little swab of it and you can put it in a machine and the machine amplifies the genetic material and says that the virus is there. But in addition to that, what we really need is that we need antibody tests. In other words, we're not just testing to see if a person has the virus. We also need to be testing to see if the person has had the virus. Because it's very likely that if you've had the virus, you now have immunity to the virus. And for sure, if you didn't show any signs or symptoms the first time you got it, if you get it again, you certainly wouldn't. You probably would be way better off, even if you don't have high levels of neutralizing antibodies. So those are the testings that we need to do. How often should one test? When we're up to capacity, I would say that, let's say we went back to school and you have a campus like NYU filled with people. I would say in order for people to be confident, you probably want to be testing at least once a week or at most once every 2 weeks. Because you could test somebody today who tests negative because they're in the window period where you don't have enough viruses to make a positive test. And then you test tomorrow and that negative person is positive. We saw that happen at the White House, where somebody tested, they before didn't have anything, 2 days later they were positive, right? Because it takes a while before the virus replicates enough and get into the saliva and into the nasal passage, so you have enough of it to get the genetic material. Testing is going to be the thing, Brother Higgins, that's going to return us to normal. If we can't test every single person that we have in a company, if we can't test every single person that we have on campus, then you're not going to be able to safely put people together in any setting where they're more than 6 feet apart to ensure that you're not starting a mini outbreak.
Thank you for that. Thank you very much. And that also applies to a question that came up about church. When will it be safe? And I think that ties in very nicely with the fact that testing will be necessary.
Right. And for church, I think even when testing becomes available and you can test people on a regular basis, you're going to have to determine who comes to church, who congregate. Because you're going to want to leave your older members and members with underlying conditions out of the initial group of people going back to church. Because the last thing you want is for a single person in your congregation who is vulnerable, who is susceptible to pick up that infection. Remember that the mere fact that we're testing and we're doing all those things, that doesn't mean that the virus is not going to be around. That doesn't mean that people are still not going to be infected. The fact is that the virus is just your canary in the coal mine. The testing tells you that the virus is there. Now you have to follow up, because it's the quarantine and the isolation and the contact tracing that's actually going to break the transmission of the virus. Once you test and somebody's positive, then you contact trace and see how many people has that person come in contact with, and you isolate those people. And you check to see who among those who have been isolated has become positive. Once they become positive, you have to do the same thing again, contact trace to see who they were in contact with and stop the spread that way. So that's why we need the testing, so that you can isolate, you can quarantine, you can contact trace.
And all right, so before we get to the caller on the line, if we can, there's 2 questions I think I can pose to you that I can kind of bunch together. Yeah. Number one is, we have several questions about safety measures for the average person. What is mask use? I know we see a lot of masks being used now, so maybe you can speak on that. And the second that sort of helps tie that in is about the reinfection rate, and especially about this new study about men transmitting it differently.
Yeah.
You can speak on that.
Good. The thing about masks, let me share my screen again where masks are concerned. The issue with masks is that not all masks are made equal. So the typical mask that you see being passed around is a surgical mask. Surgical masks were never made to protect you from viruses. So this virus can go straight through a surgical mask. So a surgical mask like this, and also the bandanas, the DIY masks that we make, those are important to protect other people from you if you have the virus. In other words, if I'm positive for coronavirus and I'm coughing or I'm speaking, that mask that I'm wearing will prevent the virus from traveling far, right? It will trap most of the larger molecules that are coming out of my mouth, and it will prevent it from traveling to somebody over. That mask is not going to protect you from somebody else having the infection and you getting it. I hope that's clear. The only mask that can protect you from the virus getting into you is that N95 mask. And that's what healthcare workers use routinely. But N95 masks are very different from what you see here. In fact, there was a case of a man who actually passed out driving in New Jersey and had a crash because he was wearing an N95 mask for too long. And then that N95 mask makes it very hard to breathe. So it's not something I would recommend people wearing around in any case. And moreover, it's unlikely that you would be able to get it. And even if you get it, it has to be fitted. So the students in my lab, the people who work in my research lab, because we work on infectious pathogens, they wear N95 masks. And when you come into my lab, I have 6 or 7 different types of it, because different brands and different types fit different people differently. So for example, my face with a broader nose bridge fits an N95 mask very differently. And each individual has to get a test, a respiratory test from a physician before to make sure that they're breathing properly. And then they have to be face fitted with that mask to make sure that there are no air outlets around it, because that's the only way you're gonna get protected. Remember how tiny these microbes are. Okay, so that's the mask issue. And I'll stop sharing.
It was the reinfection rate and the reinfection rate and how men can transmit differently.
Yeah. So at this stage, I don't see any research that definitively shows that people can get reinfected. In fact, the initial data that was published that people were getting reinfected, it became clear later that because the test is so sensitive and what it's looking for is the genetic material of the virus, that the viruses were dead and the genetic material was just not totally destroyed yet. And people were picking it up in these tests later. So it's not clear to me that people who have been infected can become reinfected. And that's one of the things that needs to be figured out. One of the things we forget is that this virus has just been around for 6 months now. There's still a lot to be learned about it. Now, we know now, based on studies that have been recently published, that it's been found in the semen of men. It's also found in the blood of people that they have found. The question is, can it infect you that way? Certainly not. You know, if you're getting it from semen going into the vaginal canal, that's not going to make you have coronavirus disease, because remember, where it has the pathology is in the lung. We know that it can also infect the intestines, that, you know, the individuals can have diarrhea as a sign of that, because the intestines have lots of cells that have receptors for it. It's not clear to me that the genital tract has high numbers of cells with this ACE2 receptor that will even lead to a localized infection. And if you did, it probably would do nothing there. So I'm not concerned about that.
Okay, we have a caller on the line. You can go ahead and pose your question. Go ahead,
Yes.
caller.
Good afternoon, doctor.
Good afternoon.
Yes, you have answered part of my question regarding the safety measures with the mask, and I'm in agreement with you. Most of these masks out there are not good, but I was told that fabric like wool, if you try to use like a wool type material to cover your nose and your mouth, that it's a dangerous thing, because the droplets, there's a possibility that the droplets will stay longer on wool material versus like a cotton or a silk material. Do you have any take on this?
Yeah, I mean, the fact is that none of these are ideal things. And if we had the proper PPE, we would never have to use, you know, handkerchiefs and napkins and any of those to utilize. The thing with those is that, as I said, what it does is that it protects others. If you actually have the infection and you cough or sneeze, it will protect others from having the virus traveling far in the air so that they can become infected. The thing is that nothing beats hand washing, you know, and real hand washing, you know, 20 seconds at least washing your hands with a good soap. Get a soap that smells good and suds a lot. It doesn't have to say antibacterial on it, because the truth is those don't do anything special. It's the surfactant itself, that thing that makes it sud, is actually the very thing that leads to the death of the virus. So when the soap hits the virus, it peels off that membrane that I was showing you that it uses to infect. And so its guts just come spilling out. And so it doesn't have much strength against those. So the hand washing is going to be important. If you wear a mask, when you're taking off that mask and handling that mask, you have to make sure that you don't then use that hand and put it on your face, because that's how you could get infected. because you're inhaling, that area around the mask is going to be more concentrated with air droplets because you're pulling them in. So when you take those masks off, you have to wash them. If you can't get to wash them right away, throw them in the dryer and run it so that the dryer cycle will be able to kill them. Or run them in when you're washing these materials, run them on the warm or hot cycle of your washing machine as well, and that can actually kill the viruses pretty well.
I want to jump in for a quick second, Doctor. And you mentioned the whole, we are going through the whole length of what we're doing to protect ourselves. I read somewhere, actually, I heard somewhere that these measures that we are taking, that the hand washing, the staying home, it actually has a back end effect on us, because it actually reduces our ability to fight infection, so that when we now come back together, that we have opened the door to a lot of opportunists, if you will, infections and diseases that can take place. Is that true? Because it seems like we're doing one thing one way to help us, and then when we come back together, if our ability to fight infections has been compromised, if you will, then when we start going back, will we see a rise in diseases, other diseases?
Absolutely not. Whatever you're immune to, you'll still be immune to, whether or not you're with people or not. So these are just myths, and these are people who don't fully understand how the immune system works. What they were trying to say is that if we stay away from the virus, then we won't develop what is called herd immunity. And herd immunity is this concept that the more people who are immune to the infection in the community, the less likely for transmission, because since I'm not getting the disease, I can't transmit it to the next person. And so, for example, something like measles or the mumps, you need over 90-something% of people in the community to be immune, to be vaccinated, for you to have what we call herd immunity. And so in London, they had decided that what they were going to do was to allow people to just get infected. And yes, they would have some deaths, but the more people were infected is the more herd immunity they would have. And sooner or later, they wouldn't have to worry about coronavirus. And now you're seeing what that just 2 weeks of trying to do that caused so much death that they immediately pivoted and decided to do what everybody is doing, which is physical distancing. Because there's never been any society that has gotten natural herd immunity. Herd immunity has always come from vaccination, because the toll on human life is way too great for us to decide to allow natural herd immunity to happen. In other words, what would happen is that everybody who is susceptible to the disease would die before you actually have herd immunity. And now we're seeing that even younger people, even kids, are getting seriously infected with this and having serious pathology. So the notion that we had in January, February, that only older folks were getting it, that has been dashed. And so we can't even say now that there's any protected part of our population, since we don't really know how this virus infects at this point.
I'm glad you mentioned children. 1 second, Brother Dwight. I'm glad you mentioned children. So we've seen an increase in children, and the symptoms and what they're going through is much different than what we've seen with adults. What exactly is the disease doing differently with children than what it's doing to adults? Is it what's called mutation of this virus? And if it is, explain to us, what does that mean?
Yeah, so we're just beginning to understand what is happening in children. In fact, for the children who you're seeing with the COVID toes, that inflammation on their extremities, those who are going into cardiac arrest and stuff like that, it seems as if they're having these symptoms towards the tail end of the infection, and it's related to inflammation. In other words, it's the response of their immune system to the presence of the virus. We still don't fully understand what is going on there. It's not a mutation. They're having the same type of virus that adults are getting. And by and large, most children just don't even respond overtly to it. and so we're not seeing anything. Where mutation is concerned, this virus luckily has what we call a proofreading system. So when we talk about mutation of a virus, let's say you're typing in Microsoft Word and you don't have spell check and grammar check and all those things on. Right? As you type, you make a mistake in spelling a word, or you have double words or some, and those are not caught. That's how mutations happen in a virus. That every time it replicates itself, it makes these simple errors, and sometimes those errors are deleterious. In other words, depending on the mistake you make, the word that you thought you were typing, it could mean something totally different. And so that can cause the virus to die, or it could cause the virus to be much better. So HIV, for example, lives by this method of making multiple mistakes in every replication. And that now sometimes creates strains of HIV that are way more virulent than the other ones. What this coronavirus has is that it has a proofreading system, right? And this is very unique. Not many RNA viruses have a proofreading system. But what that means is that it doesn't make half of the mistakes that other viruses in its cohort make. And that's good for us, because it means if we get a good vaccine, it will work against every variation of the virus that we know at this point in time. If it had a high rate of mutation, we would have to make multiple vaccines the way we do the flu vaccine against it. The challenge, though, is that what we've seen with the other coronaviruses, the MERS and the SARS coronavirus, is that after 2 to 3 years, people who got it and had immunity to it, that immunity goes away. And so we don't know if a vaccine is created, how long that vaccine will last, and we will have to get it again, or if we'll have to get booster shots, which is one of the reasons why we have to allow these vaccine projects to run their course, so that the safety is worked out and we understand the mechanism of protection.
So
go ahead, Brother Dwight.
Yes. So just to glean again, I'm gleaning from the questions coming in chat, and I'm trying to put them all together. All right. So there was, I guess these are 2 questions coming at you. The one question already was about the children, which I think was really good, and I think a lot of people had that. But this was another question. What can we then do to protect the children beyond hand washing and social distancing? That's number 1. And then number 2 is, what are some extra precautions, including home remedies? I know before you mentioned that onions and garlic was used in the past, but are there vitamins that we can take? And maybe also speak on drugs like the remdesivir that has been approved, or the hydrochloroquine that has also been approved or has been trying to be pushed out there. Can you speak on drugs, home remedy, and what else we can do for our children, since it has been said not to cover their mouth?
So here's the thing, like any other respiratory or other infections that we get, the better your immune system, the better position you're in to have a good fight in that war with that microbe. Again, this is going to be dependent on underlying conditions, but most kids don't have underlying conditions. And so having a balanced meal, making sure that they have good amounts of fruit and vegetables. You don't even have to give them supplements. If they're eating a balanced diet of balanced meals with the right amount of protein, the right amount of vitamins, and keeping them away from too much fast food and too many sweets, which counteract all of that. So anything that you can do that's immune boosting, doing juicing, doing green drinks, mixing up, some good nutrient-rich meals for your kids and for yourselves as adults will definitely be a good thing. Having them get a chance to exercise, going outside and running around safely and getting some of the sunlight will boost their vitamin D. And that will also help in boosting your immune system overall. Now, where the drugs are concerned, the antiviral drug remdesivir has shown efficacy against the virus. Here's the thing that you have to understand, that is not a treatment for people with regular coronavirus infection. This is a last line treatment for people who are in the hospital and are desperately trying to survive. So this is not the kind of drug that everybody is going to get. Moreover, there's only one company who's making it. Gilead is the company that makes this, and they haven't ramped up significantly their production of it. saying even if everybody needed it, you wouldn't be able to get it at this point. And at this point, they're not selling it. They're giving it for free to hospitals. They're giving it to the federal government, who is doling it out to different hospitals, so that if people really do need it, they can get it. Again, this is not a drug that's a golden find. It really doesn't have very strong efficacy. But for people who have the virus and they have severe illness, it was shown that they were able to leave the hospital 2 or 3 days earlier than individuals who weren't on this. And that's significant. Being in the hospital for 2 or 3 days extra could cause significant complications, especially if you have to be intubated. So that would be an important consideration. Now, hydrochloroquine, the studies have shown that hydrochloroquine actually doesn't help with this virus. In fact, studies have shown that it actually increases your risk for arrhythmias when you take it. So if you had some underlying heart condition or some other underlying conditions that impact your functioning of your heart, hydrochloroquine seems not to be the thing. People talk about garlic and onions and other things. Remember that none of these things will prevent you from getting the virus. There is nothing that you can take that will prevent you from getting the virus. The only thing you can do to protect yourself from getting the virus is just physical distance and wash your hands and doing what seems like simple procedures, but they're so very effective. We've seen that right across this country, that when people stop going out, stop finding themselves in large crowds of people, the projected number of viral cases went down significantly. And that's what we have to continue to do. So there's really no magic thing out there. People will tell you, oh, you know, if you inhale warm water and steam and stuff, that's going to kill. None of those things is true. You really have to be careful of what you're looking at and seeing on social media. Everybody says they have a remedy for this and that there's a cure somewhere that the government is not telling you about. None of those things is true. This is a highly contagious virus, and for some vulnerable people, it can be very dangerous, and we just have to be thoughtful about where we get information.
Any more questions, Brother Dwight?
Yes, there was one more that came in that it just dealt with the, so after a person recovers from the virus, what are some maybe comorbidities that could develop?
And that we don't know. And that's one of the things about how early we are in this process, that we don't know what the long-term effects of having this infection is going to be. And that's going to be really interesting. You know, there are people who said that they have lost their taste and that hasn't returned, or they've lost sense of smell and that didn't fully return. They're now researching that to see what the link is with the neurons in the frontal lobe, to see how that is tied together. And that's going to be, those are going to be the studies that we're looking out for every day. I scour the databases that I get these studies from to see if there's any new development in this. But in any infection that you see so many people get, the next step is going to be to look to see the people who are infected, what is it that they have after they've recovered from this disease? Are there comorbidities that people have that predispose them to some secondary infection or some secondary disease after having had COVID-19? I think Bishop had his hand up for a while. You're muted, Bishop.
Yeah, God bless you. God bless you. God bless you, Doctor. We certainly want to thank you for your coming and sharing your knowledge with us. So I want to revisit the vaccination question. As in our community, in our church world, there's a lot of apprehension to vaccination, even before this, and even into this. And I know Sister Diana asked a question, and you gave a very good explanation. But how are we going to manage this, even as a church community? Because we are really, really, really concerned about the vaccination. And you made some good points of that as well. So it seems as if it's going to be difficult for us to coach our people not to take or to take this vaccination too early. So that's one point. The other point quickly is with cleaning. And you talk about detergents, and that was a good point. What about the common salt? That's one thing we want to talk about. And then last but not least, I'd like you to tell me where is Dry Hill. Is that Clarendon or is that Hanover? God bless you. Thank you so much for your time. I'm impressed.
Thank you, Bishop. So Dry Hill is 10 miles north of Old Harbor. And so it borders St. Catherine and Clarendon. So Dry Hill is is about 3 miles out of Bella's Gate. Bella's Gate is in St. Catherine, but Dry Hill proper is in Clarendon.
All right, I know where that is. All right, God bless.
So when you leave there, you go down to Rock River, those areas.
Beautiful, beautiful.
Yes, sir.
All right, no vaccination. You understand? And I'm not going to go into the mark of the beast or nothing like that with you, because I'm not going to do any theology with you. But there's major concern in the Christian community with vaccination.
The concerns in the Christian community about vaccination are stemming from anti-vaccine groups that have been very savvy with their messaging. What I said about vaccine is true. There is no medication that you take that has a higher standard to meet than vaccination. Because as I mentioned before, you're giving vaccine to healthy people. What happened in the 1980s, going into 1990, is that there was a paper published in a very reputable journal called The Lancet by a physician from London, stating that vaccines, the MMR specifically, no other vaccine, just the MMR, the mumps, measles, and rubella vaccine, was leading to autism. Now, what you have to understand about that study is that this guy actually got 12 kids, actually 11 kids, samples from them who came to his son's birthday party, and he illegally got samples from these kids, put them under unnecessary procedures, and then published the paper making these claims. It had 12 authors on the paper. All of these authors later retracted their names from the paper because they realized that the data that he used was forged data and that it wasn't true. However, by the time they realized this and by the time the Lancet fully retracted this paper, so much of the world had gotten onto this story and falsely has held onto this story, thinking that there is some inherent danger in vaccine beyond what we know is regular medication. And that's where the anti-vax movement actually pivoted and became popular. Now, this physician, his license was stripped. What they found out later is that he was working on an alternative vaccine to the MMR and had a company that was paying him a lot of money to do this. And that was the motivation for publishing this paper. This is what you don't hear in the anti-vaccine movement, right? And so a lot of people come and say, I'm not taking vaccines because they're dangerous. They can cause this and they can cause that. Are vaccines 100% safe? Absolutely not. They're made by us. They're made by humans, right? And there are people who are going to have reactions to a vaccine. If you get a vaccine and there's something in there that you're allergic to, you will have a response. You know, for many people, the injection site, they have a reaction to it. However, what we do know is that people are not walking around dying from vaccines, because despite this movement, we know that 90-something% of the world population is vaccinated. What does that mean? Well, that gives us confidence in vaccinations, because it says that if vaccines were so dangerous, then people should be dropping like flies from them. And that is not happening. Now, I believe in vaccine safety, and that's why I'm very cautious about the pace at which this COVID-19 vaccine is being developed. Moreover, the platforms, the ones that are winning right now, are the messenger RNA vaccine. We have no vaccine in current use that was made that way. Why is that important? Because the platforms on which vaccines are made actually determine a lot about what we think about the safety of the vaccines. And at this point in time, if those vaccines with the new platforms are the ones that win out, I would be initially cautious to see what happens over a certain period of time to people who actually get those vaccines. And I don't know how else to say it. You cannot accelerate a vaccine timeline. The reason for the long time span of testing a vaccine has everything to do with the safety of the vaccine. Vaccines are about safety. Because here's the thing, if you get a vaccine that doesn't work, you're no worse off from where you were. But if you get a vaccine that's not safe, you're way worse off than you were before. And I think what is happening, what we're seeing, this pressure from the leadership of this country to get vaccine manufacturers to sidestep or to skip these safety steps are really, really problematic. For a vaccine, you go through preclinical trials. In other words, you test it in animals and in tissue culture, and you see if it's safe there. Then you give it to a small number of people. That's what phase 1 clinical trial is. You give it to a small number of people who are brave enough to say, I will take it. And you watch. You're not even looking to see if it works at that stage to protect you against the pathogen. That's not the important thing at this stage. The important thing at this stage is, are people developing conditions as a result of the vaccine? Is it safe? Once you realize that those people are safe, then you slowly move into a phase 2 clinical trial where you expand on the total number of people you're giving it. You move now from 10 or 12 people into hundreds of people, maybe 100 or 200 people. And you select those people based on different demographics. You want older people and younger people and people who are from different races and backgrounds so that you can see if this is safe across the board, because you might develop something for adults that's not safe in kids, right? You might develop something that shows you a reaction in the Asian population that you don't see in the Caucasian population. We need to know that. And so you watch that. That's why these phases take about 6 months apiece at the very least to develop, because you want to see what that type of reaction is. It is only then that you move into a phase 3 clinical trial, which is really where you see if it works. Phase 3 clinical trial is a prospective case control trial. In other words, you have people who get the vaccine, people who get the placebo. The doctors nor the patients don't know who is getting what. You have an independent agency who monitors that. You send them out into the population and you hope that they get exposed to the virus. In other words, if this virus goes away next week, then any vaccine that's being made now would never be completed, because you need a phase 3 clinical trial. And phase 3 clinical trial require that you have the virus circulating, and you would want to do that clinical trial in a hotspot where you have lots of infections, where you're hoping that the people in the trial will get exposed. Because if they don't get exposed, you won't know if it protected your vaccinated group over the unvaccinated group. Does that make sense? So these are the little
yes, Doc, it makes a whole lot of sense. But
yeah.
All the things you're saying now is really going to put me in a position now. If the powers there be rush this thing too quick, what are we going to do?
If they rush it too quick, I'm going to be apprehensive about taking a vaccine.
All right. Okay, thanks. That's what I want to hear.
And I'm a big proponent of vaccines. That's what I do for a living. But I also know that it needs to be safe. And so everybody's going to look at the safety information. And I can tell you, it won't be any secret. There are people out there who are skeptical enough. There are people out there who are good vaccine immunologists who are going to look at this and look at the epidemiology. They're going to call the manufacturers out on this if the due diligence is not done. But what I would say is that for the current vaccines that we have, for measles, mumps, rubella, those are safe vaccines because they've been tested. And they've been tested over many, many years. At this point, I would need to see the safety information on that vaccine. For example, one of the last vaccines we had is the HPV vaccine. And we're still getting data on the safety of the HPV vaccine from all over the world. Even though there hasn't been anything that has come up, there's essentially is a phase 4 trial that you're going into after it's widespread, just to gather data to see, is there something that needs to be tweaked about this so that it can be more safe? And I'm interested in those data.
God bless you, man. God bless you. Well, we've been keeping our ears tuned to you because somebody needs to monitor this, and it can't just come to the layman, the people outside, and say, well, take this vaccine, it's going to work. If we don't have some good concrete information, yes, we ought to take it, because we could be in a worse position.
I can tell you, I wouldn't be silent if that's something that I don't think is ready.
Right. Thank you, Doc. What about salt?
Salt, there's no indication that salt works against this virus. I'm not sure what sort of a salt solution you could have that would kill it and how that would be administered. I know that there was this guy in Canada and another one in Jamaica who said they made these masks that have salt in it as a protection. But their mechanism suggests that they think that what's going to happen is that the salt solution will dry and the salt crystals will pop the virus open. Now you have to understand why that wouldn't be true. The salt crystal is something you can see with your eye. I told you that you could have 1 million of these viruses on the head of a pin. In other words, the salt crystal to these viruses will be like a mountain. These viruses are technically not alive until they get inside of a cell. And so salt crystals, in my opinion, might encase the virus and prevent it from binding to its receptors if you have enough salt. But outside of that, I don't see the salt itself killing the virus in any short period of time unless it's in solution and then it dehydrates the virus. You know, when salt is around, what it will do is pull the liquid, pull the water out of the virus, and that could potentially make the virus less efficient. But at this stage, I don't think that salt is a remedy for this infection.
Yes, thank you, Doc. Enough of me. God bless you.
God bless.
Great having you, man.
Thank you so much for having me.
Thanks, everyone. Time is really going on. So we have 2 questions left before we're going to close the chat, because we can keep the doc on the phone on the Zoom all day, which we won't. So the first question, and then I'll go to the person with the hand raised with the iPhone, says, if heat is an element that kills a virus, what would you say with regards to people going out on a hot sunny day thinking they will unlikely contact the virus? What would you say to people's behavior on hot sunny day?
I would say put on your sunscreen and do everything, as the Bible says, you should do everything in moderation, right? If you go out and try to unnecessarily expose yourself to the sun, you're going to get skin cancer instead of the virus. So you don't want to do that. Because again, as I said, while the virus can be killed by sunlight, if it's already in your body, the sunlight is not going to have any impact on it. You know, what it will do, the sunlight will kill the virus on a surface, but not if it's already inside of you or if it's covered under mucus. It takes a longer time before the sunlight is able to do that. In other words, you don't have to do anything extra. The being outside is a good thing. The fresh air is good for us. So you should take in some of that and getting some vitamin D and getting yourself healthy. But at the same time, you don't want to be in a position where you're going outside trying to kill a virus that you probably don't even know if you have.
All right, thank you. Okay, the caller with their hand raised, iPhone, you may go ahead and pose your question.
Good afternoon. Good afternoon, doctor.
Good afternoon.
My name is Diane. And as a clinician in the hospital, one of the things that we're seeing is an increased cardiovascular risk and thrombotic events, such as heart attacks and strokes and even pulmonary emboli. So patients are being discharged on blood thinners. And my concern is there are people that are infected with this virus who are asymptomatic. So are they now at increased risk for having a thrombotic event at home? Because we are hearing of cases of people who are dying at home from having such events. So, and also that African American are bearing a higher disease burden when it comes to the coronavirus. And we do have a higher disease burden to begin with as it relates to heart disease and diabetes. So do you recommend an aspirin? I think folks should be educated on the increased risk of having a thrombotic event and also on the signs and symptoms of heart attacks and strokes, and when to call 911.
Yeah, I completely agree with you on the education about heart disease in general. And yes, that's one of the things that I'm seeing now being published on a regular basis about the fact that this virus is able to cause significant thrombotic events. In other words, when you get infected with the virus, a significant proportion of patients are having blood clots formed in their system. In fact, this doctor was describing it that he realized this because some of the patients, they have kidney damage as well. When they put them on dialysis, the dialysis machine is clogged because of the clot. And so these result in pulmonary embolism and other conditions resulting in stroke. I was talking with a physician friend of mine at Vanderbilt, and he actually explained that physiologically, because the virus binds to ACE2 receptors, These ACE2 receptors are actually the same receptors that are on the cells that line blood vessels. And he thinks that that's what's leading to these thrombotic events. I haven't seen any studies yet looking into that to see if these blood clots actually have platelets in them, or if it's just clotting factors pulling together red blood cells and other cells there. But it certainly is a concern. As to whether or not people should be taking aspirin, I think you don't want to do that unless you've talked with your physician, because that might not be indicated for some people based on what you have. But if it's okay with your physician, especially for people who have other underlying conditions of hypertension, and if you have an underlying condition of having had blood clots in the past, that might be something to take a baby aspirin on a daily basis, because that might counteract the clotting. What I have to tell you, though, is that most of the physicians who have reported on this, when they put the patients on blood thinners, they didn't improve significantly. So I don't know if it's because they were too far gone at that stage and had so many clots that it was hard to just get rid of those, or if it's that there is something that the virus is inducing that's actively counteracting something like Coumadin or heparin that these patients were prescribed. So that, I think, is going to be interesting. You mentioned the disparity that we're seeing in African-American population, and that continues to be a concern. This whole pandemic has highlighted the great health disparities that we have in this country. It has widened the divide between the haves and the have-nots. One of the first things you saw is that for people who thought they had symptoms and they wanted to get a coronavirus test, outside of getting taken to the hospital, you could go to these sites that you drive through and you get tested, right? However, what that did is that it prevented people who did not have a vehicle from ever getting tested, right? If you didn't have a vehicle to drive through those sites that they had, you never got tested. Again, the poorer people. The poorer people as well, of which we find in our African-American communities, are the ones who are most in most of the essential jobs, where you have to be front-facing for people. You know, you're working jobs as doormen, as janitors, as service people, and you can't leave and stay home. And that, I think, has also affected the rate at which we've seen this virus infect in the African-American community. But the other thing that we've seen is that you mentioned the comorbidities, and African-Americans overall, and those of us of Caribbean descent as well, we come already with underlying conditions, high levels of diabetes, high levels of heart disease, high levels of COPD, chronic obstructive pulmonary disease, and some of these other conditions that put us at a very high risk of serious morbidity and immortality when we get exposed to a virus like this. And so that's where you're seeing the disproportion in the numbers of African Americans. I don't know if there's a genetic link yet. It's something that's being explored. In other words, based on our genetic makeup, is there something that makes us more likely to have these types of diseases, these comorbidities when we get infected with the virus? That we don't know yet. But what is clear is that the health disparities that we have complained about for decades in this country have been clearly highlighted in this pandemic. And this disproportionate death that we're seeing is clearly something that we have to look for. The other part that's not highlighted is that more men are dying than women from this disease. And that also, that started in China, it's clear now. And that also is not clear why that is the case. And so there's a lot to learn about this virus.
Doc,
thank you.
Thank you so much for your time. I just wanted to really quick before we pass off, to acknowledge Winsome's iPad. I know somebody in the video was raising their hand. So it is now your opportunity to ask your question.
I'm sorry, I was not raising my hand.
Okay.
I might have enthusiastic.
Okay.
Oh, you were just stretching, I'm saying.
Yeah.
So we're good.
Is that it, Brother Dwight? Do we have all the
there
questions?
was one last one. There was one that just came in about alcohol. Does alcohol intake what is the effects of alcohol?
Well, the excessive use of alcohol will damage your liver, and your liver is where most of these proteins are made, including the clotting factors. So the fact that this is already causing a clotting issues, you might want to ease up on the amount of alcohol intake. At the same time, the truth is that, you know, alcohol does kill this virus, but not when you ingest it. When you take in alcohol, it gets into your cells really quickly, so it doesn't have any effect on the virus. But if you have something over 70%, in Jamaica, that's what you would call the kulu kulu. That can kill the virus if you dilute that down to 60-70% alcohol.
Yeah, Doc, and tell them as well that it's against the church procedures and practices. And
yeah, I didn't want to say that because,
yeah,
of course.
I'll help you with that, Doc. I'll help you with that.
Are we through with the questions, Brother Dwight?
Yes. Yes, we are.
Okay, great. So, Dr. Webley, we certainly want to say thank you so very much for spending this part of your afternoon with us. We are truly appreciative, and I'm sure we're in a setting where I could just reach across the aisle and just shake hands and just say, you know, thank you so much for educating us, making us more aware of ourselves and how we should proceed going forward. I will say I have your contacts, and as things develop and as more information is known about what we're dealing with, we certainly would love to invite you back to give us an update on where we are and what we should be mindful of. So again, our sincerest thanks and appreciation for just dialoguing with us and just bringing us up to speed as to where we are with this disease.
Thank you so much for having me. Thank you for all of you who have participated by asking some really, really great questions. It's clear that you're a great family together, and your bishop should be very proud of all of you. You are taking the time out to get the right information. But as believers in God, as people who believe in God, I just thought I'd leave this with you. In the book of Isaiah, chapter 43, verses 1-3, the Bible says that, do not fear, for I have redeemed you. I have called you by my name, and you are mine. It says, when you pass through the waters, I will be with you. And through the rivers, they shall not overwhelm you. When you walk through the fire, you shall not be burned, and the flames shall not consume you. For I am the Lord your God, the Holy One of Israel. This is the same God who says, peace I leave with you, and my peace I give to you. And I don't give you the way the world gives it to you. Mm-hmm. So do not let your hearts be troubled or be afraid. So I invite you, as the Bible says, lift up your eyes to the hills from whence your help comes. Because in these types of situations, when we get fearful and we're discouraged and we're dismayed, we know that our help comes from the Lord. So I'll end by quoting 1 Peter 5 and verse 7, where Peter there says, cast all your anxiety, all your cares on him. Why? Because he cares for you. And so throughout this, we can't forget that we're believers in God, that God is still in control. No matter how chaotic things might get in your communities, in your families, don't forget that God is still in control. And the God of the mountains is still God in the valleys. The God who helped you yesterday and last year is the same God who is in charge right now. And he will certainly carry us through and give us a testimony and strengthen our faith so that we can make it to the kingdom, which is his goal. I thank you so very much for having me.
Great. Thank you so much. And with that being said, the only thing I will add to that word is David said it clearly in Psalms 56:3, whatever time I am afraid, I will trust in thee. And with that, I'll turn over to Elder Hector, closing remarks and closing prayer in Jesus' name.
Bless the Lord, praise God. We certainly thank Dr. Webley again. I know it's been said presided by Evangelist Hector, but we want to say it again. We are so grateful for you taking the time. And I'm smiling at the end because a lot of times we get these, and I use the term scientists, and there is no God in them. And part of the bio didn't tell you that he is not only a scientist, but you can hear the scriptures coming out. So you are quite aware that he is no stranger to the word of God. And so we had that added blessing in him being able to end, praise God, with quoting scriptures that are certainly essential to us. I also want to take the time to thank each and every one that came on. While we're grateful for Dr. Webley, but we wouldn't be successful if we didn't have all those who attended the meetings. And I know we have folks from Jamaica, from Canada, from Florida, from all over, certainly from New York, New Jersey. And so we give God thanks for everyone coming on, praise God. And I am not going to close. Actually, I'm going to take a page from my pastor's book because I do have a presider on. He's asked his question, but I'm going to give the closing role over to him, which I think is the most appropriate thing to do. So, Bishop McCoy, hand over to you to close up for us in Jesus' name.
God bless you, Elder Hector. God bless you, Evangelist, and God bless you, Elder Dwight as well. And Doc, we certainly, I said it already, man, we really feel good that you were able to join us. And as Elder Hector said, the preaching is good. So the next time, no science, we're just gonna have you preach for us, man. That'd be great. In the name of the Lord. God bless everyone. And certainly you have learned something today that will make your life a little bit easier. And certainly we're ready for whatever comes because we believe in God. Eternal God and Father, we thank you for your goodness and your mercy. We thank you for the doc that has come to join us. We thank you for the invitation. We thank you, God, for his willingness to share with us and our willingness to listen. We pray, loving God, that you'll bless us. Lift our thoughts above every suffering of this time. Give us glimpse of glory as we move through this in the name of the Lord Jesus Christ. We're looking unto you, who is the author and the finisher for our faith. We commit ourselves in your care in the name of the Lord Jesus Christ. And now unto him who is able to keep us from falling and to present us faultless before the presence of his glory with exceeding joy, to the only wise God our Savior, be glory, majesty, dominion, and power, both now and forever. God bless everyone. Greet somebody.